The guy who got the Airbnb dataset.
That's it.
I took was the number of Airbnb listed and the average price. So
Spatial data science lets investors, real estate agents, small renters, and rent to rent folks crunch location based info to make smarter moves, like spotting hot markets.
I don't know.
hey guys, welcome to a brand new episode. And today we are going to continue the last episode where geo data science, after around 5-6 hours of work, we have finally completed the whole thing. Obviously, there was an immense help from our friends and also GPT. That is going to be under low. But if you can see our laptops, yes, you can. I'm gonna tell you what's actually very interesting about this project. So the first thing that was really interesting was, come on man, let me just open up this. So there is somebody whose name is Austin, Texas. What was his name? The guy who wrote this thing, the guy who got the Airbnb dataset.
That's it.
It's not that even, bro. I think it was like Mixel or something like that. Okay. Hey. Who is Murray Cox, the person who made Inside Airbnb? So his name is Murray Cox, and he made this whole data set, which you could see right now here.
Oh, you mean Murray Cox? That's the guy behind Inside Airbnb. He scraped and shared all that public data on listings to show how it's affecting housing in cities. Pretty cool project, right? If it's not him, what's the context?
Tell a little bit more about him and Inside Airbnb, please.
Sure. Murray Cox is this cool data activist and artist from New York. He kicked off Inside Airbnb back in 2015 as a way to expose how short term rentals are messing with housing markets and neighborhoods. Basically, he scrapes public Airbnb data, crunches it, and shares free data sets plus killer visualizations for over 100 cities worldwide. It's all about empowering communities to push back on gentrification and stuff like that. Super useful for researchers, too. What spurred your interest in it?
Guys, if you guys are into rental properties and flipping it, this is an amazing website, and it's only updated in 12 months. So right now we are doing the data for 2020. You could get it for 2023 if I'm not wrong. So if you can see the screen, I can pretty much do anything. Like, these are all the countries and places. I can even go London, and if I do this, I can see all the Airbnb listings inside London. You can see these red things are all listings, and even I think if you download the sheet, it's pretty interesting because yes, you can see this is, we did it for Austin, Texas, and you can see listing type from the Airbnb website, the scraper ID, source, the name of the condo or the listing, the description. This is what was very interesting for me. So this is for Austin, Texas. So you can see here, people who are new to Austin with jobs or full-time college students are preferred. You may be working and looking for your ideal space or home. So my home is great short-term solution. So the description under the Airbnb is also being here. So our project inside the code, you can see here, what we are doing is, first we are actually taking this data set, but since this data set is not having a proper geodata mapping, which is very complicated. If you know, like there is a lot of types of maps, right? So if you can see like how globe is, okay, I think ChatGPT is better. So tell me more about spatial data science and why spatial data science is important, and what are the different types of spatial data science, and like how a globe when extrapolated onto a flat plane can have various types of maps and conventions, which has pros and cons for distance, and how structure of the countries are there.
Spatial data science is basically using tools and techniques like GIS, remote sensing, and geospatial analysis to explore, analyze, and visualize info tied to locations on Earth. It's huge because space shapes everything from city planning to climate change tracking, disease outbreaks, or even business decisions like where to open a store. Without it, we'd miss patterns in geography that affect people daily. Think traffic flows or flood risks. It's grown massive with tech like GPS and big data. Types? Well, there's vector data like points for cities, lines for roads, polygons for borders, which is great for precise shapes. Then, raster data. Think grids of pixels from satellite images, perfect for continuous stuff like elevation or temperature. There's also graph-based for networks, like transit routes, and even 3D models for buildings or terrains. On maps, projecting a 3D globe onto flat paper always distorts something: size, shape, distance, or direction. Mercator keeps shapes accurate but blows up polar areas, like making Greenland huge compared to Africa. Robinson balances looks but messes distances a bit. Equal area, like Mulwade, preserves sizes but warps shapes. Pros: Mercator's handy for navigation since straight lines stay straight. Cons: it exaggerates high latitudes, which skewed colonial views back in the day. For country structures, equal area shows true landmass. Africa's way bigger than Europe, while conformal, like Mercator, keeps coastlines crisp but hides how vast Russia really is up north. Which part grabs you most?
Okay, so most of the conspiracy videos out there saying map is not really blah blah blah. Actually, the science behind this is this whole geo data science subject. So as you can see here on my laptop screen, so this is the globe, right? So imagine this is the globe that is assuming Earth is spherical, not flat, right? So we need to make this globe into a flattened plane. And I think in engineering, I studied some theory about this, and there was one equation, and that is used to convert anything which is in a round format into a very flat plane. So when you are doing that, you could actually cut the globe into many ways, and each way you cut, right, you can create a flattened plane, but that will be, there is a cost function for it. So either some countries might be big, right, or if you cut like the most of the time when you and me look at the map which is given to us from school or anywhere outside where you buy the normal maps, you could really see like some countries like Greenland and all is very large compared to Iceland, which is not actually true, because like Africa is very big, but compared to US and all, like the size of the continents distorts once we put it in a plane. So that, you can see this image represents it's better. It's not an alien, but you can see this 0 0 is like the size of the each of the country. So if you go to the end of this area, the size of 0 is big. So these countries will be having a bigger space when it is actually drawn on a flattened map. So you can see, oh, this is the thing. So you can see these are all types of maps, and as the map changes, the size and distortion changes. But you might be thinking, okay, then there is one map which doesn't distort anything, so can't we use that? So if we use that, the road network will not work. So Google Map that we use in our phone is using a particular type of map setting so that the roadways are more having priority rather than the country size or something like that, you know. So each map has its own advantages and disadvantages. So we need to choose the right map setting to extrapolate this data, right? So let's go back to this code. So what we are doing here is, first we are doing pulling all the data from the inside Airbnb database, right? For our particular case, we are doing on Austin, Texas, and then we are actually also pulling all the geo data of Austin, Texas, right? Or a geo map of Austin, Texas, so that this inside Airbnb data set doesn't have that much accuracy in the map. It only has data of what is inside the map, if it makes sense. If it doesn't make sense, it doesn't make sense. It'll skip this information. It's not really relevant. So the next thing is like we combine two tables, that is like Austin, Texas and the Airbnb table to the Austin, Texas longitude and latitude and city table, right? And we merge these two so that we get a very precise location of each Airbnb to the correct state or inside Austin, Texas, or the correct county inside Austin, Texas, right? And then this is what we are having. So I could take numerous questions, but now one of the questions that I took was the number of Airbnb listed and the average price. So this is what we are trying to import and put it on the Austin, Texas dataset, right? After many tries, this is not the first file. I think these three are all files, and I had to, it was a hectic of a thing. So then what we did was do the population density. So we had another table or another data set, which is, so if you go to any GOV government data set, you can actually pull up mean and median of any mean population density, how much population has been there in each state, right? So that was pulled. I'm not, give me just, okay. So this is the website, actually it's called Census Bureau, and here you can actually download the data like mean population, median population, or population density of a certain area. So we kind of did that. We pulled data from there and kind of put that in the map and represent it. On top of it, we are also where is DND, bro? DND. Okay. So then, what was the last step, bro? What did we do? Right. So here you can see, this is kind of the whole point of this project, which is here you can see the median of income. So these people who are having green, more greener side of the green, right? If it is more like bluish green, then that means that he is doing really well in life, at least financially. Mental health wise, no idea, but financially he will be able to pay rent. So if I am renting or if I am buying a place here, then, or if I am like leasing a place here, at least the person will be able to pay the rent that I am putting out or something like that, right? So this is a really amazing thing, which is very underlooked and overrated at the same time, I guess, because most of the government, the professors who are teaching us are really excellent, as well as there are teaching assistants as well, and these people are actually working with the government to understand how population is going here and there and all. But I think this can be actually done in any business settings as well. So if you need any help in this, you can contact us and we can go through it. Yeah, bro. So it's not 2 days of an issue, okay? It's like we did it, right? So we stumbled a lot. It was a funny project, but eventually, yes.
Yeah.
Eventually, yes.
It was 2 years and we didn't.
But the point is, right? If we can do it in 2 days, we can do it. I have full confidence in myself.
I know.
Okay. So that is pretty much everything I want to. Can you give a pretty much summing of geodata science and how much usefulness it can be to any people who are like investors, real estate brokers, real estate investors kind of stuff? Can you can you actually give a more detailed explanation on how geodata science geo so how geodata science can be used by investors, investing firms, real estate agents, small time renters, rent to rent business models, and give us a detailed explanation on how we can be using it in a certain country, where to buy kind of stuff, and how also we can connect different types of data from different websites and calling different APIs as well. Dude, we had an API, right? What was the API name?
Does it?
Spatial data science lets investors, real estate agents, small renters, and rent to rent folks crunch location based info to make smarter moves, like spotting hot markets or dodging risky zones. For example, in a country like India, you could layer census data, property listings, traffic patterns, and even air quality stats to pick the best buy spots. Start with tools like QGIS or Python libraries, ArcP, GeoPandas for mapping. Pull real estate APIs from Zillow or local ones like Magicbricks to get prices and trends. Connect transit APIs, say Google Maps, for commute times, weather APIs for climate risks, or even social media for neighborhood vibe. Mix it all in a dashboard, say high income zones near new metro lines in Mumbai, low flood risk. No single API does everything, so you chain them. Fetch Airbnb data for rental yields, overlay satellite imagery for green spaces. Pros? Pinpoints value, like undervalued areas near future infrastructure. Cons? Data gaps or privacy laws can snag you. For rent to rent, map demand spikes, like near colleges during term time. Got a specific city in mind?
Not really, but probably you found out the whole sum of it. We would not be continuing geodata science episode anymore, so signing off.